Hello, welcome to the class today. So in this class, we will continue the 10.2 and we will do the arc length and the surface area. Okay, so firstly, let's take a look at the arc length. How to find the arc length for parametric curve? Firstly, let's take a look at our calculus 2. Okay, in calculus 2, we know how to calculate arc length. So the formula is given by this one. The arc length is A to B 1 plus dy over dx squared dx. Okay, let's have a quick review how we get that formula. So for a given curve, this is dy, this is dx, small arc. Okay, so if we choose small arc, we draw a rectangular, and here small height is dy, small length is dx. To show our arc length, we can say that is small s. Okay, s equals root of dx squared plus dy squared, right? And if we take dx out, so it becomes, if we take dx squared, like factor dx squared out, this becomes 1 plus dy squared over dx squared. Okay, so which is 1 plus dy over dx whole thing squared dx. And if we write the whole arc length, which is limit of the sum, okay, sum I and goes to infinity. So sum I from 1 to n. So which is limit of Riemann sum actually. And this is just, integral a to b 1 plus dy over dx squared dx. Or we can just write down 1 plus y prime squared dx. Right, we learned this in Calc 2. So here's just a quick review. So in our parametric equations, what is the arc length? Let's take a look. So arc length formula is this. For regular function. So in our parametric curve, so our variable is going to be t parameter. It changes from alpha to beta. And here, let's see. Derivative dy dx for parametric curve, which is dy over dt over dx dt. We studied this at the beginning of this section, right? Derivative. That's the first thing we learned. So it's going to be dy over dt over dx over dt whole thing square. And what is dx? Dx, just take derivative of x. So which is dx dt and dt. Okay. Now we put this into the square root. So alpha to beta. When we put into the square root, it becomes square, right? And times 1 is dx over dt squared. And cancel with the dx dt squared at the bottom, becomes dy over dt squared and dt. So that is the formula for parametric curves. Okay, let's box this formula. That is number 3, arc length. Here's the formula. Now let's take a look at the example. Example 4, find the length for the unit circle. So for the unit circle, we know the parametric curve equations are x equals cosine t, y equals sine t, t from 0 to 2 pi. Okay. So this means one circle, right? So right now we're going to use the formula to find the arc length. Let's set up the integral. Alpha to beta, for this case, is 0 to 2 pi, and the square root dx dt over, let me write down the formula firstly, and then we plug in the functions dt. Okay, So it's 0 to 2 pi dx over dt, which is negative cosine t squared, right? And the dy dt, which is cosine, just the derivative of sine, which is cosine. And here we can see sine squared plus cosine squared. Okay, the first one should be negative sine t. So this becomes sine squared plus cosine squared, which is 1. And you can see this is 2 pi. This is exactly the same as the length for the circle, which is 2 pi r, right? 2 pi r, and the unit circle r is 1, which is 2 pi. So you can see this is the unit circle is the basic one. Let's take a look at the exercise problem. Set up the integral. You don't need to solve. So here the first one. X equals t minus t squared. T from 1 to 2. It's just calculation. After we set up the formula, right? We'll set up the integral. T greater than negative 3 and less than 3. Okay. So I'm going to give you the formula here. Give you the answer. The first one, arc length equals 1 to 2 derivative of dx dt 1 minus 2t squared, and the derivative of y prime, so which is 4/3 times 3/2 t to the positive 1/2. I square it, right? Square it, so it becomes 4t, because t to the 1/2 power squared becomes t, and then just dt. The second one, negative 3 to 3 square root e to the t squared, which is e to the 2t, and plus 2t squared, which is 4t squared, and dt. Okay, so here you don't need to evaluate them. Next thing we're going to do is the surface area. Let's have a quick review of Calc 2. So in Calculus 2, at the beginning, we learned the volume and the surface area of the revolution, right? So if we have a curve, like a function, and if we rotate this about, x-axis or y-axis, then we have those formulas. So the surface area for rotate about x-axis is given by this one. 2 pi y ds. This is rotate about x-axis. And the other one is 2 pi x ds. ds means small arc length, okay, about y-axis. So this is for the Cartesian, like a coordinate function, regular function, y equals fx. So right now, for the parametric equations, it's very similar. So we just change bound for t alpha to beta. So 2 pi, and the y is still just yt. And the ds, here we plug in the arc length formula. So which is dx dt squared, dy dt squared, and dt. So this is the ds. Okay, it's just arc length. Number 3, the last formula we learned. This is about x-axis. Same thing for the about rotate about y-axis is given by. Just turn this into xt, and arc length, they're the same thing. dx over dt squared plus dy dt squared. Those are the two formulas for the surface area of the parametric equations. Okay, now let's take a look at the example. Example 5. X equals cosine t y equals 1 plus sine t, parametric equations, and t from 0 to 2 pi. So rotate this about x-axis. Okay. So by using the formula, alpha to beta is 0 to 2 pi, and here 2 pi about x-axis, then we do y, so 1 plus sine t. And the square root dx dt, negative sine t squared, dy dt, so cosine t squared dt. So same thing, this one equals 1 because of the identity. So our integral becomes, so I'm going to take the 2 pi out because it's just constant, right? So we don't want to include that in our integral. Make the integral a little easier. So 1 plus sine t and dt. Okay, that's our integral. So now just calculate this one. 2 pi times pi, and the integral sign should be negative cosine, and from 0 to 2 pi. Okay. And it's going to be cosine 2 pi and cosine 0 are both 1. So when they subtract each other, so just 0, you can just ignore that term. So 2 pi times 2 pi, final answer should be 4 pi squared. You can try this exercise problem. X equals cosine t, y equals 3 plus sine t, t from 0 to pi, about y-axis. Okay, you can try this. I will give you the solution later. So that's all we need to know in this section. 11.2 is all about the calculation of parametric equations. So let's have a quick summary. I will give the solution later, okay? Summary for this section. The first thing we need to know is how to find the slope of the tangent, or just the derivative of the parametric equation curve. So that is dy dt over dx dt. And also the second derivative. Be careful, it's not just the derivative of the first derivative. It's going to be derivative of the first derivative and then divide by another dx dt. Okay. The second thing we need to know is, first is the derivative, third is arc length, the second is area. Okay. And the arc length, surface area. So the area equals what? The formula is A equals alpha to beta. Y, so you don't need to memorize the formula. So that's before we have this one, right? So here just yt, dx is x prime t dt. Okay, arc length, alpha to beta, dx dt squared, dy dt squared dt. And the surface area, you need to say is about x-axis or y-axis. So about x-axis, 2 pi y, arc length, 2 pi x, arc length. Same thing, and the alpha to beta, alpha to beta. Okay, so we can stop here in this section.